long time, people have wondered why the structure of the solar system bears so many similarities to the structure of an atom. Beyond the stunning and impressive images of the universe, this similarity also stands out as a notable highlight in scientific research. From the tiniest atoms to the vastest cosmic systems, their organization and structure both play a crucial role in helping us understand the natural processes that occur. So why does this similarity exist, and what does it mean? When compared, we can see that the atomic structure and the solar system share many similarities. But this is no coincidence. The reality shows that there are fundamental physical and mathematical connections between these two systems. First, let's explore the structure of an atom. An atom is composed of three main components: protons, neutrons, and electrons. Among these, protons and neutrons bind together to form the central nucleus. The electrons move around the nucleus, forming an electron cloud that surrounds it. The entire atomic structure is built from these microscopic components, atomos. Accordingly, matter is composed of simulated particles, and atomic theory is merely one of many interpretations of the nature of matter in space based on empirical data. However, we can certainly describe the solar system in a similar way. The solar system consists of many planets, moons, and other celestial bodies. The gravitational force from the Sun creates a central gravitational field, causing these celestial bodies to move continuously without stopping. The overall structure of this system resembles the electron cloud model surrounding the nucleus in an atom. So what caused this similarity to appear? A possible explanation is that both are the result of the same natural process governing the behavior of matter in the universe. The stable and unstable states form due to the interaction between these forces along with the dynamics of matter. The concept of resonance arises from the interaction between matter and the fundamental forces of nature. Moreover, the similarity in the mathematical formalism of quantum mechanics between the two systems suggests that there may exist a deeper connection between them. Some hypotheses suggest that the universe is fundamentally composed of subatomic particles and larger observable structures. For example, the solar system is a newly formed phenomenon resulting from the interaction of these particles. If this is true, then the similarity between these structures may reflect the fundamental unity of the universe at the subatomic level. Another explanation for the similarity between the structure of the solar system and the atom is the concept of universality in nature. Universality refers to the concept that certain physical laws and phenomena can be broadly applied across different systems and scales. For example, the laws of gravity governing the motion of planets in the solar system also apply to galaxies and the entire universe. Similarly, the behavior of electrons in an atom follows the principles of quantum mechanics that govern the motion of particles at the subatomic level. The concept of universality suggests that the similarities between the structure of the solar system and the atom may stem from the universality of physical laws and phenomena. The hierarchical structure, stable configuration, and unstable resonance phenomenon are all typical examples of a common occurrence across various systems and scales. The prevalence of physical laws and phenomena suggests there may be a profound connection between the structure of the solar system and the atom, or we could also interpret this similarity through the Coulomb potential acting between them. Coulomb potential is a fundamental concept in physics, describing the interaction force between electric charges based on factors such as charge magnitude, the distance between them, and the dielectric constant. In an atom, protons and neutrons form the nucleus, while electrons are bound at energy levels around the nucleus to maintain the atomic structure. In the solar system, the Sun has an extremely large mass, so its gravitational force keeps the planets and satellites moving in stable orbits. This gravitational force, which is based on the Coulomb potential, also determines the orbits of planets and the Moon around the Sun. On the other hand, this similarity can also be reasonably and objectively explained through data and empirical research by the scientific community. For example, in physics, researchers have discovered certain similarities when comparing the characteristics, properties, and physical quantities between the solar system and the atom. Based on the Coulomb potential model in the atom, scientists discovered that they have a structure very similar to the solar system in terms of size, density, and mass when studying planetary systems resembling the atomic model. An atom is an extremely small and electrically neutral particle. The structure of an atom consists of a positively charged nucleus surrounded by a shell made up of one or more negatively charged electrons. The atom has a structure so similar to the solar system that many have theorized this universe might itself be a gigantic cell. Some people believe that the universe is actually a living being, with a breath and the warmth of a heart. This hypothesis is called the organic universe theory. The foundation of this perspective stems from the hypothesis of a prototypical life form, akin to a primitive first living organism or cell. Ultimately, it evolved into a vast, self-sustaining ecosystem with internal equilibrium, capable of self-regulation, becoming the foundational framework that constitutes the entire universe. According to scientists' hypothesis, this prototype of life follows natural laws and forms the structure of the universe in an orderly manner. Specifically, this bottom-up organizational form continually emerged during the unceasing evolutionary process following the Big Bang. Additionally, there is a hypothesis suggesting that the boundary between organic matter and ordinary matter is quite blurred. And the boundary between life and death is essentially a continuous process with distinct stages. Thus, the entire universe is composed of interconnected life forms, like a living organism or cells. It is worth noting that the hypothesis about extraterrestrial life has not yet been convincingly proven. And the scientific community also expressed skepticism and caution when approaching this issue. A living system like a cell encompassing the entire universe might be too vast and complex for us to clearly prove its existence. And it is also very difficult to verify this through experiments or other methods. The reality is that our current understanding of this field remains very limited. Whether the universe is a cell or not remains merely a hypothesis and is still in the preliminary stages of scientific exploration. And further exploration and deeper research are needed to provide the most accurate and reliable answer. Despite fundamental differences between the two structures, such as size and the nature of their components. However, commonalities such as hierarchical structure, stable and unstable configurations, resonance phenomena, and the application of quantum mechanics have been demonstrated. The similarity between structures may stem from the fundamental forces governing the behavior of matter in the universe. The concept of universality in nature may reveal a more fundamental and profound connection between these two structures. This study has made a significant contribution to expanding human understanding of the universe at various levels, and may reveal deeper insights into the nature of the universe.